Once you have some properties of integrals under your belt, a good exercise to do is to take an integral you know, such as the integral from 0 to pi of sine of x, which we don't know but we'll find in a minute, and then ask some questions, some other questions by varying the limits of integration. And sine is a good one to do because it has some symmetry that we can utilize. So first let's take out our calculators and evaluate the integral from 0 to pi of sine of x. So for those who've never done this before, you'll want to go into your, there's two ways to do it. One is to go into y equals, put in your sine function, make sure you're in radian mode, and go adjust your window, make sure that it's reasonable. I made mine from 0 to 2 pi for my x min and x max, and then my y min and y max I'm going to make -2 to 2. And then you'd hit graph. And then what you're going to do is you're going to go to second trace, or in other words, the calculate button. And you're going to go all the way down to 7 where you see that integral symbol. You press enter, and then it asks you for the lower limit. We're going to put 0. Enter. And then the upper limit, we're going to put pi. And then you actually see it shade in the area, and it gives us our answer, which is that this integral equals 2. So we see that this area here is 2. Alright, so from here we can ask, I could ask a couple other questions. I could say, what's the integral from pi to 2 pi of sine of x? And here I would just expect you to use some intuition and understanding of the symmetry of sine in addition to your properties of definite integrals. Right? There's pi, there's 2 pi, and we know that that area is going to be exactly the same as the area from 0 to pi, but it's negative, so we need to count it as negative. So that would be -2. I could give you something like this. 0 to 2 pi of sine of x. And so in this case we're just taking the integral from 0 to pi and essentially adding it to the integral from 0 to 2 pi. We know we want to count that as 2, and that counts as -2, so this integral should end up being 0. Let's see, I could do something like this, 0 to pi over 2. And here, I'm essentially asking you the area from 0 to pi over 2, so I'm asking you for this area here. And again, using symmetry, we know that the area from 0 to pi, or the integral from 0 to pi, is 2, so this must be half of that, so that should be a 1. So in any case, these are good exercises to do. I'll probably do a couple more just to get us in the swing of things and able to evaluate these. So here I'm going to ask you to use a little intuition. So now I've got from 0 to pi of 2 sine of x, and we haven't really talked about what it means, what that 2 should be doing. I mean, we know in terms of the graph it's going to stretch it vertically by a factor of 2, but in terms of the integral we haven't talked about what it does. But hopefully intuitively you might at least try factoring it out, or removing it from the inside of the integral and bringing it to the outside, and you would be completely correct in doing that, because integrals are essentially limits, and so they can behave like that. So you can take out constants. So that means that's just 2 times the integral from 0 to pi, which is 2 times 2, so that should be 4. And it makes sense. When you vertically stretch a function by a certain factor, the area is going to scale by that factor as well. Let's just finish with a couple more. I'm going to go on the next slide to give more space. Yeah, so once again, we're looking at a couple of integrals that we can compute using just properties and our knowledge of the sine graph in this one integral. So here's another one we could consider. Negative pi to pi of sine of x dx. And if we look at the graph, there's sine from 0 to pi and from negative pi to 0. And we know that this area has 2. So the integral from the negative pi to pi, well, it's going to have to count that as negative 2 plus the 2 that we get on the interval 0 to pi. So that's going to give you a net area of 0. And I guess I'll finish with this one. Changing it up a little bit. So I'm bringing in cosine. So let's remind ourselves what the cosine graph looks like. It looks like this. And if we're going from 0 to pi, there's pi, we can see that the area from 0 to pi over 2, we don't even need to necessarily know what that is, even though we do know what that is. Think about the cosine graph as just being a sine graph that's been shifted. This is half of one of those peaks, I guess. And so that should have an area of 1 in this first quadrant. And then by symmetry, from pi over 2 to pi, you're going to get the net area being negative 1. So 1 plus negative 1 also gives you 0. So there's just an exercise in practicing some properties of definite integrals given a nice definite integral whose value we know, and then just utilizing symmetry and those properties.